Hey, what's up YouTube? Alright, so we're doing this. There's no backing out now, as I have the tendencies to start a lot of projects and not finish them. So, doing this on YouTube, all 42 days. This will be, there's no backing out. Okay, so let's kind of go over some of this. The last couple videos we talked about how tritium's original kick control model is kind of like the linear model that we have. It's just a simple degree per minute, except our linear model here that we've demonstrated on the vibe code repo, we can do an adjustable number of days and then do an exponential moving average across that degree per minute data to kind of get the latest and greatest weighted to more recently a linear degree per minute. And then we also have these different kind of fancier mathematical models that the PNNL white paper talks about. So this will be a math challenge where 1 week on each one of these models. So it's kind of intimidating for me, so I haven't really got into really hard stuff like matrix algebra, so let's just see what this looks like. And also just a reminder that this model 3, the hardest one of course, the paper says performs the best. And what it means by that is that so basically these math models will feed in, just like the optimal start blocks, will feed in zone temperature, a set point, and then we'll be looking at the schedule next time and next value. And this is what the math model takes in this data. And then ultimately we're predicting minutes to warm up or cool the zone. So basically this 42-day challenge will kind of get into the meat of this. So what kind of, how hard will these mathematical models be to do on our own without being a PhD engineer? So let's try that. Okay, so this is our week 1. Let's dive into this linear model. So this is all of this is kind of this lesson. All these lessons plans are created by ChatGPT in Gemini 3. So I think they did a really good job actually, and I'm having some other people like the PhD engineers actually come over this too and put their blessing on it too. So I'm kind of excited. This will be something I hope to specialize in. I kind of think this is really interesting. Algorithms in the edge device environments, and then also some of this mathematical modeling stuff is kind of cool. Alright, so here we are. So we're going to spend an entire week, 7 days on a linear model, degree per minute, and how long it takes to warm up or cool down our zone. And then our model does get a little fancier that we can hold a lot more data than just 1 day than tritium's optimal start, which only holds 1 day. We can hold 10, 15 days of data. So this is model 0. Alright, so I'm just going to scroll down here and then jump right into, this is it. So we'll be doing this. This will be week 1. Week 1 right here, day 1, day 2, all the way down to 7. So specifically today, this should be pretty easy just to do the first lesson here in Python. So I'm going to go into the lesson details for day 1. Alright, so first, before we even get set up with this, if you're new to Python, you can do, I'm on Windows, so Python, Windows, downloads, and then this will go, this is python.org, and then just find the downloads for Windows, and then you can just do, I think I'm still on version 3.13, but maybe I'll just install whatever they have is fine. for this type of stuff. If you were doing like some really fancy web application development or some data science or something kind of hard and fancy and specific, you might be forced to use older versions, which is kind of common to any programming language. But for this stuff, we don't even need any external libraries. Okay, so let's just install. Here's the Windows executable. So I always like to hit this path button right here. Install now. And then do the yes. And there's not much to it. Looks like we're still waiting for it to initialize. While that does its magic. Seems kind of funny why it's taking so long. Usually it's very instant. And then another thing that is kind of optional, which I can demo, you don't have to do this, but I use VS Code as an editor, but Python also has a built-in software development kit called idle. But this is something I like to use too, which I can demo too. So this is it's called Windows Terminal. It's free. It's a free app from Microsoft. So it makes it look like the Linux command prompt. So like for example, if you looks like that's installing. Like if you get a command prompt. Computer's going really laggy for some reason. So this will bring up the command prompt. Where are you? So that's on my other monitor. So this is just a Windows command prompt. You can run Python from here. And then if you have this Windows terminal for Windows PowerShell, it just looks a little fancier. It makes it more Linux-like. So I can demonstrate that here too. And there's really easy ways to run Python files. So okay, Python was successful. So this is Python 3.14.2. I guess is their latest and greatest. So let's just see if we can demonstrate this. I'm gonna have to search for it here. So I have Python, I guess I have a couple different versions. So here's Python, actually 3.12. Okay, so this is the built-in editor that's built into Python. So I think I can just create like a file here, and I'm just going to just show you a demo. Like if you're new to Python and you're new to all of this is probably the easiest way to get started, is to just use the built-in IDE with this called idle. I wouldn't use it for anything else, but if you're doing something really fancy like web app development or playing around with the Python backend stacks or something data science, you probably wouldn't use idle. But for just really simple math stuff, I think this is totally fine. So if you could just do like 4 times 4, maybe make a variable, let's say product equals 4 times 4, and then you just do print product, and then you can just hit run, and it is asking what this is asking for. I haven't used idle for a while, so actually it's wanting to save the file first. So I think I can just do this here. I'll just say test file. And this should be on my desktop somewhere. So where'd you go? Now I just have to find it. So anyway, so if you, now that it's saved and you just run it, voila, there you go. So you can, you know, if you have like some kind of error print, you know, this will error out the script. See, you can just copy this paste it right back in the ChatGPT, or you could even do, you know, screenshots right into ChatGPT. You know, you can do anything really. So it's up to you. I'm just trying to find my Python file. Oh, here it is. So if you're new to Python, you can probably just use idle, which is easy, or else if you want to use like a really fancy code editor that more of like the software engineers use, I use VS Code, and then this is what I'll be doing because it's kind of something I'm more used to doing, but I have definitely used idle for long time before getting into VS Code. So don't feel like you have to do this. And then this is actually where the Windows that Windows Terminal app is running. Looks like Linux. So I'll be running Python files like this, but you don't have to do this. Like you run it from the command line. So test Python. You know, it'll do the same thing as I showed you earlier. Okay, so let's see if we can pump out a lesson. So I might even open up ChatGPT, and maybe I'll even download this, and also I might even download this guy too. Just give ChatGPT a little something to look at. So if I don't think you have to do this, but I think like later on as these lessons get a little harder, it might be nice to chat with AI on some of these concepts because they might get kind of hard. And I'll probably be trying to learn something too. Okay, so here we are, day 1. Okay, we're doing it. No backing out. All 42 days. You heard me. Might be skipping a few days here and there, but I'll catch back up. But this is actually not 32 days. It's actually up to 42 now, so I'll have to correct that. Okay, so day 1 lays the foundation. It focuses it on the change, which is the triangle symbol, how fast it changes, and how these concepts relate to degree per minute numbers in these. I guess AI is calling it model 0, but something, it's the model 0. We're calling Niagara's model model 0. No heavy algebra, just intuition defines it in a few tiny exercises. So in HVAC BAS work, delta simply means how much did something change. It's nothing more than a subtraction. For optimal start problems, we care about temperature difference, so we define delta T as the set point minus the zone temp start. Whereas zone temp set point is your occupied set point. Zone temp and start is the building's temperature, where when the building begins, that's it. The delta is just the difference. So the rate of change is the slope. So warm up is all about how fast the temperature rises, degree per minute. So that's where we just divide the delta by the time, delta time. So in model 0, it's the rate of change is literally degrees per minute, and it's in a slot that we have in the Niagara program object in Java land is degree per minute. So why this matters for optimal start, how many degrees per minute are you away from the set point, delta T, and how many degrees per minute can the building warm? Then you can predict the warm-up time with a simple division, which we talked about. Okay, so here we go. Mini exercise. This one should be pretty quick and basic. So let's say that it's Wisconsin. It's now so our buildings will get cold when overnight and the HVAC is off. So our delta T is 7 degrees. So we could even go like this. paste this right into here. Surprised that maybe it doesn't like the minus, didn't like that symbol for some reason. Alright, so then in Python we could actually just run this pretty easily. Delta, just do the up arrow, you can run that in idle and see, there we go. 72 minus 65. Alright, here we go. So compute the rate of change. So our rate of change will equal, so we need a time. Time equals 35 minutes. So, this is pretty basic. So our rate will be our temperature divided by time. So we can do rate equals delta temperature divided by time. Copy that to you. Okay. Something doesn't look right. Okay, so I guess so we could even do some more prints. You could do like out of here. Okay, so delta. Sometimes I like doing these things. You can print like a little string around there. File again. Alright, so 7 and 7. So this is degrees for the units, and then this would be degrees per minute as a rate. Alright, so then we're doing predict the warm-up time. So T. Alright, so they're saying that predict the warm-up time. So capital T is the triangle, 4 degrees, the rate of 0.2 degrees per minute. How many minutes will it take to warm up the zone? So that's 20 minutes. So 4 minutes times degrees per minute, 20 minutes. Okay, try this exercise on your own. Calculator or pencil. I'm going to use Python. So compute the zone temp. What is the delta T? Okay, so they want us to do 67 and 72, so I'm going to go back here and go change you to 62 and 67. What is the delta? Alright, so we'll have that covered. Compute the rate. What is the warm-up rate? Okay, so then if I'm just gonna go redefine this. So they want for this computing the rate to use 64. And then if I print this data will get redefined. 30 minutes. So actually we don't even need the minutes in this first part. But only in here. So if I do put this to 20 is what they want, and we don't even need this yet. So this is number 1. Python, we can comment things out. So this is number 1. This is number 2. What is warm-up rate? Okay, so predict. So then now we predict. So we're kind of inside the optimal start block, and we're actually pretending we're inside the optimal start block, and we're going to try and predict how many minutes will it take to warm up that zone. So here we go. So we take little t divided by our rate. Actually, it's the same thing. So we just divide these two numbers, like the example here. So, okay, so let's do number 3. Okay, so number 3, so our delta, they give us the delta right away, so that's just value of 6. Our rate is 0.25, which they give that to us right away. So then minutes equals delta t divided by rate. Nothing very hard. I'm just going to do minutes equals delta t divided by rate. There. So I just have to copy that. Ta-da! Alright, so, and what I'll probably be doing on these courses is actually, doing stuff like this. I'm probably chatting with AI because I know this is going to get really hard really fast. So how's A1 less than, okay, I know this is very obvious and easy right away, but I could even just upload the Pi file directly. So AI is my teacher, so here we go. Your lesson 1 is looked like they didn't say that anything was wrong, so here we go. Alright, we're doing this. So day 1 is done. Maybe look for day 2 tomorrow. So I'm probably going to end this video right here. And yeah, so this is probably going to get really hard really fast, and I'm definitely not an expert here, and this is somewhere where I want to learn. I think it's like a really important concept here. And it's probably one of the most powerful energy saving strategies there is. Like if we are optimally scheduling HVAC, which I honestly think very little of that is done in industry, in the world. Hats off if you are. I think this is a place where we can improve a lot as a whole. So thank you for watching, and stay tuned for the next lesson.